Welcome to our latest video on the electrolysis of brine, sodium chloride solution. This video is suitable for GCSE students. By the end of this video lesson, you should understand that ionic compounds can conduct electricity when melted and dissolved in water. You should also understand that sodium chloride solution, brine, forms different products to molten sodium chloride when it undergoes electrolysis, and you should be able to name the products that form during the electrolysis of brine, understand their uses, and be able to write electrode equations to describe what is happening at each electrode. Now, in previous video lessons, we've discussed the fact that ionic compounds conduct electricity when you melt them or dissolve them in water. And ionic compounds are compounds that consist of a metal and a non-metal. So for example, sodium chloride is classed as an ionic compound because sodium's a metal and chlorine's a non-metal. Now, in an ionic compound, there are no molecules. Instead, there are billions and billions of plus ions and negative ions, all stuck together in a giant structure which we call a crystal lattice. And this structure is very strong, and the positive ions and the negative ions are held together by electrostatic forces. And we've shown you different pictures of what a lattice looks like, and some are shown on this slide. Now, in a solid form, the ionic compound does not conduct electricity because the ions, the positive ions and the negative ions, are not free to move. However, when you melt or dissolve an ionic compound in water, the lattice breaks down, the ions are free to move around, and therefore the compound conducts electricity. And in this video, we're going to focus on aqueous solutions, solutions where we've dissolved the compound in water. Now, as we discussed in previous videos, this is the type of apparatus that you would use to carry out an electrolysis experiment. You would need a power supply, a source of electricity. You would need electrodes, and the electrodes dip into the solution that you are going to be breaking down using electricity. This solution is called the electrolyte, and you would have connecting wires to connect the power supply to the electrodes. Now, in our previous videos on electrolysis, we have concentrated solely on molten solutions. And if you melt sodium chloride, your two products would be sodium and chlorine. Now, this is because in molten sodium chloride, the only ions present are Na plus ions and Cl minus ions, sodium ions and chloride ions. And the Na plus ions are attracted to the negative electrode in electrolysis. And when they attract to the negative electrode, they gain electrons to form sodium metal. And on this slide, we can see the electrode equation that shows this taking place. Na plus ions would gain one electron to form Na. And the reason they gain one electron is because an Na plus ion has one less electron than a sodium atom. This process is called reduction because reduction is a gain of electrons. Now, at the positive electrode, the anode, the Cl minus ions lose electrons to form chlorine gas. And we've written the electrode equation here. 2 Cl minus ions minus 2 electrons goes to Cl2. And there's an alternative way of writing this where we move the electrons onto the other side of the equation, and it becomes 2 Cl minus ions goes to Cl2 plus 2 electrons. Either is okay. And this process is called oxidation. So in molten sodium chloride, there are only two possible products that you could have, and that is sodium and chlorine. Only two products because there are only two types of ion present, Na plus ions and Cl minus ions. The problem with using molten solutions for electrolysis is that ionic compounds have very high melting points. So an alternative to using a molten solution is to use an aqueous solution, an ionic compound dissolved in water. However, if you carry out an electrolysis experiment with sodium chloride solution, sodium chloride dissolved in water, instead of melting the sodium chloride, you have different products. Now, the reason you get different products if you have aqueous sodium chloride is because instead of just having Na plus and Cl minus ions like you have in molten sodium chloride, you also have water. And water, although it's a covalent compound, can split up into H plus ions and OH minus ions. And this means you have competition for the electrodes. So if we start with the negative electrode, Na plus and H plus ions are both positive. And in theory, they could both be discharged at the electrode and undergo reduction. However, it's the H plus that wins this competition and gets discharged at the cathode, and the Na plus ions remain in the solution. So when the H plus ions are discharged at the negative electrode, they gain electrons and form hydrogen gas. And the electrode equation is shown on this slide. 2 H plus ions plus 2 electrons goes to H2. And that is reduction, because reduction is a gain of electrons. Now at the positive electrode, we have competition between Cl minus ions and OH minus ions, which are both negative. And it's the Cl minus ions that wins this competition, gets discharged at the electrode and loses the electrons to form chlorine gas. So each Cl minus ion will lose 1 electron to form a chlorine atom, but remember, chlorine goes around in pairs and exists as Cl2. So 2 Cl minus ions will lose 2 electrons to form a chlorine molecule. And this process is called oxidation. So my two products at the electrodes are hydrogen and chlorine. Now, there is another product in the electrolysis of brine, and that is sodium hydroxide, because the Na plus ions and the OH minus ions lose out to the H plus and Cl minus ions in terms of being discharged at the electrodes, but they remain in solution and they can react together to form sodium hydroxide. And the three products from the electrolysis of brine are therefore chlorine, which forms at the positive electrode, hydrogen, which forms at the negative electrode, and sodium hydroxide, which forms during the process. And all three chemicals are important for the chemical industry. So an important question is, how can we tell what product is going to form in the electrolysis of an aqueous solution? And to help us, we have this simple rule. If you are carrying out an electrolysis experiment with an aqueous metal compound solution, you will always get hydrogen forming at the cathode if the metal in the compound is more reactive than hydrogen. So if we take our example that we've just covered, we've got sodium chloride solution. Sodium is more reactive than hydrogen, and therefore hydrogen is formed at the cathode. Now if we had a solution and the metal was less reactive than hydrogen, we'd have the metal forming at the cathode. So you have to remember, if the metal in the metal compound is more reactive than hydrogen, when you do an electrolysis experiment with a solution of that compound, you will get hydrogen gas forming at the cathode. Now the reason for this is down to reactivity, because the most reactive elements form the most stable ions, and they are less likely to be discharged at an electrode to be converted back to the metal. So if you look at this table here, you can see that if we were dealing with sodium chloride solution, hydrogen is a less reactive element than sodium. Sodium is a more reactive element, and therefore its ions are more stable and less likely to want to convert back into sodium metal. So in the examples you're going to cover in the GCSE exam, you just have to remember, if the metal in the metal compound is more reactive than hydrogen, you will get hydrogen gas forming at the negative electrode. Now there is also a reactivity series for negative ions, and the reason you've got chloride being attracted to the positive electrode and not hydroxide is because the chloride ion is the less reactive of the two. It's important to mention that you're not expected to learn this table or even go into this much detail. You just have to remember that if a metal in a metal compound is more reactive than hydrogen, you will get hydrogen gas being formed at the negative electrode. Now this slide shows a diaphragm cell which is used to carry out the electrolysis of brine. And I'm showing it to you because it summarizes the process. You start with sodium chloride solution, and that solution will be concentrated. It would have a lot of Na+ ions and Cl- ions present. And during the electrolysis, the two products at the electrodes would be chlorine and hydrogen, because H+ ions get attracted to the cathode, they gain electrons and they form hydrogen gas, and the Cl- ions get attracted to the anode, the positive electrode, they lose electrons and form chlorine gas, and Na+ ions and OH- ions remain in solution, react together to form sodium hydroxide solution, and the sodium hydroxide solution is your third product. Now during this experiment you make sodium hydroxide, which is an alkali. It's a strong alkali, and alkalis are the opposite of acids. So therefore during the experiment the pH of the solution will increase. Now when carrying out this experiment you might want to test the products that are forming. So if you want to test to see that hydrogen is forming at the negative electrode, the test for hydrogen is to have a lighted splint, and if hydrogen is the gas that's forming, it will go pop. And to test for chlorine, you have damp litmus paper, and it will go white because chlorine is a bleach. So now let's talk about the uses of the products in the electrolysis of brine. So hydrogen has lots of uses. It's used as rocket fuel. It's used in the manufacture of fertilizer along with nitrogen. It's used to make hydrochloric acid, and it's used to turn unsaturated oils in the margarine industry to saturated fat. You should also be familiar with the uses of chlorine. Now chlorine is used to make bleach. It's used in swimming pools to kill bacteria. It's also used to make hydrochloric acid, and it's also used to make PVC, polyvinyl chloride, which is used in guttering, window frames and Wellington boots. Now sodium hydroxide is the final product in the electrolysis of brine, and it has many uses. Sodium hydroxide is one of the most common alkalis in the world. It's used as a main ingredient in oven cleaner. It's used to make soap. It's used in paper manufacture. It's used to make drain cleaner. It's used to make detergent, and it has lots and lots of uses in the chemical industry. So now we're going to test your understanding of this topic by getting you to attempt some practice questions. So we're going to show you a series of questions. We like to read the questions, pause the video, have a go at them, and then we'll go through the answers. So here's question 1. This comes in 2 parts. Read through the question, pause the video, have a go at the first part, and then we'll look at the second part of this question. So here's the second part of the question. So it's asking you to complete an electrode equation, and then it's asking you why universal indicator turns purple during the electrolysis of brine. Pause the video, have a go at the question, and then we'll go through the answers. So let's go through the answers to question 1. Now the reason that hydrogen and not sodium is formed at the negative electrode, the cathode, is because sodium is more reactive than hydrogen. It's above hydrogen in the reactivity series. So if you said sodium is above hydrogen in the reactivity series, or sodium is more reactive than hydrogen, or even hydrogen is less reactive than sodium, you get a mark for this. Now if we go through the second part of this question, you're asked to complete the electrode equation for the reaction at the anode. So it'd be 2 Cl- ions goes to Cl2 plus 2 electrons. Because remember, Cl- ions lose 2 electrons during this process because oxidation has taken place. So if you completed that equation, you got 1 mark. And then it's asking you why universal indicator turns purple during electrolysis is because sodium hydroxide is formed or is present in the solution, 1 mark. And sodium hydroxide is a strong alkali. You get the second mark for saying that sodium hydroxide is a strong alkali. That's why it goes purple. So here's question 2. We're asking you for the electrolysis of brine to name the product forming at the negative electrode and to write an electrode equation to show formation of this product. Then we're asking you to suggest how you would carry out a test to prove the identity of this product. And then in part C, we're asking you to name the product forming at the positive electrode and to write an electrode equation to show the formation of this product. And in part D, to suggest how you would carry out a test to prove the identity of this product. So pause the video, read the question through and have a go at it, and then we'll go through the solutions. So now let's go for the answers to question 2. So the product forming at the negative electrode is hydrogen, 1 mark for that. The electrode equation is 2H plus 2 electrons goes to H2. There's a mark for that. How you would test to prove that it's hydrogen is a lighted splint near the gas, 1 mark, and it goes pop, 1 mark. And part C, the product forming at the positive electrode is chlorine, 1 mark for that. And the equations, you could either write 2 Cl- minus 2 electrons goes to Cl2, or you could write 2 Cl- ions goes to Cl2 plus 2 electrons. And how you would test for chlorine is to put damp litmus paper near to the gas, and the damp litmus paper would go white if chlorine was present. So our final question involves the electrolysis of aqueous copper chloride solution. So for part A, explain why copper metal forms at the negative electrode instead of hydrogen gas. For part B, write an electrode equation to show the formation of copper at this electrode. For part C, name the product that would form at the positive electrode in this experiment. And part D, write an electrode equation to show the formation of this product. So pause the video, have a go at the question, and then we'll go through the solution. So now let's go for the answer to question 3. So this question is all about the electrolysis of copper chloride solution. So the reason that copper metal forms at the negative electrode instead of hydrogen gas is because copper is less reactive than hydrogen. 1 mark for that. Then you're asked to write an electrode equation to show the formation of copper at the cathode. So this would be Cu2 plus 2 electrons goes to Cu, 1 mark for that. The other product that forms at the positive electrode, the anode, is chlorine. And for part D, the electrode equation would be 2 Cl- minus 2 electrons goes to Cl2. Or you could say 2 Cl- goes to Cl2 plus 2 electrons, 1 mark for that. So that concludes our video. So now all that's left is for us to check that we understand the lesson objectives. So after watching this video, you should understand that ionic compounds can conduct electricity when melted and dissolved in water. You should understand that sodium chloride solution forms different products to molten sodium chloride when it undergoes electrolysis. And you should be able to name the products that form during the electrolysis of brine, understand their uses, and be able to write electrode equations to describe what is happening at each electrode. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @Radachemistry.